Hello everyone, welcome back to my class regarding lesson 4 basic pattern for data analytics, HR retention prediction. In this sector, we are going to talk about model generation, finally to the fun part of predicting who is going to leave the employees and who is not. So first of all, before we move on into training the models and generating the models and per se, let us do and prepare the data for model generation first. So first of all is that we want to make sure that all the categorical values, non-numeric data, is numeric for the models to use. So I won't going to go much detail to that, but let us try to do it. Right? First of all, we want to make sure that we have salaries low, medium, and high, and we want to make it to 0, 1, and 2. Okay. So first of all, we have salary equals to df.salary. So I'm getting the salary df, and what I'm going to do is that I'm going to map them. So I'm going to open a dictionary of low becomes 0, so means the lowest, medium becomes 1, and finally high becomes 2. And I want to see it whether it's really true or not, that it changed, and just get salary. And there you go. So 0 represents low, 1 represents medium, 2 represents high salary. Okay. Alright. So after that, what we want to do is that we want to drop the left and cells and put the left at the y. So y is basically a variable that we want to find, or target variable. So how we can do it is that first of all, x, what is x? X is basically all the df except for left and cells. So we drop left cells, which is a department, and afterwards we want to make sure that the axis is 1. So axis equals to 1. So we drop left and cells, and afterwards what is y? Y is basically df left. So this is y. You run it, no problem. And afterwards we can train the model. So to train the model, we need to import the existing libraries and we pre-process them. So this is basically splitting the training sets in a random way. So for example, you have let me check. Can test this. Yep. Yeah, so basically you want to make sure that you have you have the training set, so you want to make sure that the data that you have, like for example the acting observations that you have, whether they live or not, you want to separate them. Training means that the data that are put inside the model, and afterwards test means the data that we will use the model to evaluate on. So we pretend that we don't know the result of this data. We ask the model to actually predict the data. What do you think of this profile of people, whether they're going to kill it or not? Okay, so just think about it that you will get x string. X is the predictor that is not the target value, the one that we are looking for. Test is basically x test is the predictor of the values that we want to test on. Y train is basically the left column of the values that we train the model with, and Y test is basically the target variable column of the data that we want to evaluate towards. Alright? Okay, so first of all, we want to initiate SVM object. So, but before we initiate, we need to import the libraries. So what we need to do is that, actually I think that this is really important. Yeah, here. So the library is there. So what we need to do is that if you want to initiate, then try and type together with me. SVM equals to SVM dot, then there are a lot of choices. But the one that we are interested, if you are not wrong, is SVM. It stands for support factor specifier. Okay, it is simple SVM. Okay, and we want to feed the SVM object with the train data. So what we can do is that we have here this SVM fit, and what does fit include? Fit includes text string and one string. So we run it. Text string is not defined. So you can see this means that the model has been generated. And finally, you want to find the scoring method. So you do accuracy equals to DLF dot score. And this score will contain both X test and the Y test and the Y. So it will predict X test and then use the comparison to predict the Y test and see hand in hand about the prediction models and the Y test, how accurate it is, how many the same values. And it runs. So if you want to display it, accuracy, and you can see the accuracy is 0.951. So it's a very good accuracy, 96% that you can identify. But we'll see whether it really works in the subsequent if we have real data. Okay. So we can actually come up with the predictions directly. So I just do this Y test and then X test and then whether the left or not. And if you see that the comparisons of the Y test and whether they leave, it's actually more or less you can see all of them are the same values except for 1 or 2 like this. 1, 2, okay. Alright. And just do head, then it's 2.5. Alright. So now, after SVM, we want to see the trained decision tree model. So we use decision tree instead of SVM and then we compare how the result is. So to get the tree, then we can do CL tree equals to tree dot decision tree classifier. Inside, I think I can put a lot like criterions, splitters, next step. So all of these are some configurations. But in this section, for deep visualization purpose, I like to put next step equals to 3. Okay, so I run it, and I do have a visualization code here. I don't expect you to understand because it is quite a bit sort of like complicated. It's another library called GraphVis. So basically, GraphVis does is that given a visual representation of a certain model, please give me a visualization. In this case, I want the visualization of the tree. Okay, so I do the tree and I save it as a tree.png and show it for your use. So if I run this now, oops, there is an error. Okay, let me rerun this. Okay, I don't know what happened. Give me a minute to find out. Okay, hi again. So basically, I tried and okay, sorry for that. So the reason why is after I started it is because that I did not feed it properly. So I just added on tree.fit train one chain. And the reason why there was such error happen is because the model is the empty model. So it doesn't have any values inside. Therefore, it has child error. So child error is just a tree kind of model that it doesn't have any values inside. So that's what it says. So after I generated this chart with the data, so this will visualize the data for me using the GraphVis. And inside the data, it will give me another new perspective to see what feature or what factor is important to predict whether a person is going to live or not. So for example, if you are going to see what happened here is that you can see there are some branches here. So it is going to true, and it's going to false. And after it's going to true, then it's going to talk about a certain conditions. So at the top level, you can see conditions here. Number of projects, satisfaction level. So if satisfaction level is less equal to 0.65, then that means it's true. But if it's false, then it goes here on the right side. Alright. Then it move on again. Number of projects is false or true, and it goes here, true here. Notice here that the samples is 11999, which is all the samples. And if the branches also, if you combine the sample, like 3341 plus 8658, it equals to 11999. And the value is basically the left value, whether it's 0 or 1. So means that 9172 to 827, if it's plus, then 1199. So what does it mean? It means that there are 9,172 people that do not live, and 2,827 people in this node that live. And we go on, the number of values here is different. The values here is different. So all it says is just like how many people that live and how many people that do not live that come out in this node. Okay, node is this box. So what are we interested here is at the end sample. Like you can see here that here has quite a lot of percentage of people that live, and here there are a lot of percentage of people that live, which is at the index 1 of this value list. Okay, 6x9 and 1225. So what it means is that for people that live, usually it has the characteristic of satisfaction below and equals to 0.465, true. Number of projects is below or equal to 2.5, and last evaluation also below to equal to 0.575. There you go. So these are the underworked people. They don't work that much. But on the other hand, if you want to see here, then we can go through again what the profile. So satisfaction level is below or equals to 0.65. Number of projects is below or equal to 2.5. False, so means that it's bigger than 2.5. Okay. Satisfaction level is below or equals 0.115. If that's the case, then if yes, then 689 people that have these characteristics actually quit. So this is based on the historical data. But this historical data, the hope is that it could reflect the future. It could reflect our optimum values. So given a certain profile of the satisfaction level below 0.465, number of projects below equals 2.5, satisfaction level below equals to 0.115, we expect the model will definitely 100% classified as 689, whereas it's not 100% if you do it with others. So this is quite important because decision tree keep doing it with the predictors and then keep pruning it, means like cutting down not useful features to the point that the one that you see on top has quite the lowest Gini. Satisfaction Gini is basically the level indistinguishable, because how distinguishable is it from the number of the count of the people that live and not live. So that is based on the difference of this 9172 and 257. Okay, so we want to distinguish them, and this is how historical data push that. So it's very useful because decision tree here model is quite intuitive. We can actually reflect it on here, and SVM maybe not so much, but definitely we can see that from this model that there are some characteristics that we actually will miss if we use Excel or maybe just exploratory. With that, I would like to put an end to this model generation. Afterwards, we are going to talk about training multiple classifiers and evaluating these models, followed by the conclusions and challenges. Thank you so much for listening to my tutorial. Sampai jumpa and see you again in the next lesson. Bye bye.